MacMaths, let's do some maths today. Statistics. Okay, so welcome to this statistics series, chapter 2. Now we're just about to start. I am doing a really sort of basic lesson, this first one. It's only going to be short, just reminding you of the mean, median and mode, the effect of adding data and what that has, increasing the size of the amount of data to the actual average. But I am a little bit that's different from GCSE. I'm going to look at sort of notation. So although it's basic, still stick this one out. The next lesson is going to be really important, because the next lesson after this, when I look at 2B, I'm going to introduce interpolation. Make sure that you sort of watch this, but do make sure that you do watch the lessons, even though they are incredibly dull. Okay, so let's have a look at this then. So I'm just going to go through the mean, median and mode with you. The obvious, the basics, very, very quickly, of course, because this was all done at GCSE, and it's even at foundation GCSE. But just reminding you of a few points that to make you sort of think. So just move that over there. First of all, just starting with the basics, I've got 1, 2, 3, 4, 5 numbers here, and this here measures of location. So that is the position. They call it in the chapter, this first bit is about central tendency, and of course we're looking at the center of numbers, a number that represents all of them, a position there. So that's the centre, and that of course is an average, what we call an average. And what is an average? An average is a number, one single number that represents, or best represents, the whole set of data, isn't it? So let me think of an example of that. When a baby is born, everyone asks the weight of that baby, going, "Oh, how heavy is it?" And the mum or dad proudly give the weight of their baby. Now, a baby, I mean, I don't know how heavy babies are in kilograms. I suppose about 3.5 kilograms is your average, I suppose. So let's just say that's true. So 3.5 kilograms is the average weight, the mean weight of a baby, a newly born baby. Where's that come from? So across the country, across hospitals in the country, they may do a survey and they weigh 10,000 healthy babies born, and they add all those 10,000 weights together, and they divide them by 10,000 to get the mean weight of 3.5. So now that is a middleish sort of number. It's central tendency, and so we use averages to compare, don't we, or judge other data by. So for instance, if a baby is born that weighs more than 3.5 kilograms, we go, "Oh, that's more than average, that's a heavy baby." Or less, 3 kilograms, "Oh, it's only a little fella," and so on. So it's then used to compare others, and obviously if it deviates, the weight deviates too far either way, then it may be an indication that there's going to be problems or whatever that we don't want, and so on. So that's what an average is, isn't it? It's a middleish sort of number that represents the data. Okay. So it's not the only sort of position that we're going to be looking at. When it says location, we're going to look at quartiles and so on, and other percentiles in this chapter. Okay, so different positions within a set of data. So let's have a look at what you know. You know how to calculate the mean. Okay. Now this is where I'll come in and just talk about notation here. Okay, so obviously when we're given data, they usually we'll call them values, these sort of variables, and these variables, they may label them as x. Okay, and so the mean is the sum of all of this data divided by how many there are. Okay, and if you've not seen it before, but I'm sure you have, the symbol for the sum of, okay, is this sigma. It's a Greek capital S, the sum of. So the sum of x means the sum of all those divided by n, which is how many there are. Okay, so you'll often see this, and actually there's a symbol for the mean, and the mean is that x, but with a bar over it. So if you ever see this x with a bar, it means the mean, and you'll see variations of this, the sum of over n, but we'll look at that written in a different way in a minute. Okay, so there's the introduction to the notation that I was going to talk about for the mean. And if we do this, of course, the sum of all of those x values there is 30, and there's 1, 2, 3, 4, 5 of them, so divided by 5, it is 6. So that average, the mean, is 6. Okay, we might look at the median. Median, as you know, is the middle number. We've got to put them in order first to find the middle. So when we put them in order, it doesn't matter whether we go biggest to smallest or smallest to biggest, the middle one will still be the middle one. So if we go 3, 5, 6, 6, 10, you can see there that the middle one is 6. So the median is also 6. And I picked, you know, some numbers where there is a repeated number, so we could say that the most common number. It's not often used as an average, but it is used. The mode is 6 because it's the most common. Okay, the mode is different, isn't it? That you know, it doesn't have to be a number. So if you sit and look at the colour of cars and say, oh, red's the most popular colour, you could say that red is the modal colour of car. So the mode can be qualitative, whereas the median and the mean are always quantitative, are always quantities, and we talked about that in the first chapter, didn't we? Okay, and when we talked about types of data. So there we go. So you reminded what the mean, median and mode, you knew that anyway. What about the effect of adding data to an average? Okay, so we're looking at what happens, you know, one of the aims of this was to look at what happens when we add another bit of data. How does that affect the mean, the median and the mode? So let's add another bit of data to this problem. Let's just say that we didn't have 1, 2, 3, 4, 5 numbers, but we had 6 numbers. Okay, so let's add another one to it. Okay, and let's add the number, that's quite a big number, 50, to this set of data. Now if we add a number, it's going to affect, or it could affect, the mean, median and the mode. Let's have a look at the mean first of all. That if we add a number that is the same as the mean, it's not going to affect it at all. It's going to be sort of straight in the middle. But if we add a number that's bigger than the mean, it's going to slightly pull it up, because we add all the numbers together and divide by how many, so it's going to slightly pull it up. And if we add a number that's slightly less than the mean or less than the mean, it's going to pull it down. So if we add a very big number or a very small number, it's going to pull one way or the other by a bigger effect. Let's have a look at this one. If we added 50 to this, well, these numbers already add up to 30. So another 50 means that the sum of x is now 80. And of course, n has changed. There's not 5 numbers anymore. There's 6 numbers. Okay. So 80 divided by 6, I did the maths before, is 13.3. So by adding this, we could call this like an anomaly or an outlier. You know, it's very different, isn't it, than these numbers here. So it's now pulled the mean up from 6 to 13.3. How does that affect the median? Well, if we put the 50 on the end, they're already in order, so it's in the right place, isn't it? The middle number is now halfway between these two central ones, so that's shifted along, but actually it's still halfway between 6 and 6, which of course is still 6. So the mean has gone up to 13.3, but the median has stayed at 6 and the mode has stayed at 6, because there is another 50. It's not a bimodal, there's not 2 modes, there's just, the mode is still 6. Okay. So sometimes, like, mathematicians will ask you which is the better average to use. Well, remember what an average is. It's meant to be a middle-ish sort of number that represents all of the data, the best it can do. And if you look at 13.3, well, 13.3 now is quite a way, isn't it, from, let's put it in here because they're all in order. 13.3 is, you know, is here, isn't it? It's not representing that 50, the 13.3, because it's miles away from that, and it's actually bigger than 5/6 of all of the numbers, okay? So it's bigger than all of these, so it's not really representing them either, and particularly not these ones down here. So it's not a good average to use. Okay, so that has made it not a great average. It's not really representing any of the numbers, perhaps like the 10. The 6, however, the median, has not been affected by, in this case, by this outlier. And it wouldn't be affected if this was even bigger. If we'd stuck a million on the end, this would have been pulled right up and not represent any of the numbers. But if we'd put a million on the end here, the median, it still would have been 6. It would have been unchanged. Okay, so as the median, is 6 a good average to use for these numbers? Well, it doesn't represent the 50, but it represents these numbers. You know, it's in the middle of, 5 out of the 6 numbers. So it's a good average for the majority of the data. Okay, so it's a better average to use. So just be aware of that sometimes, the median is not affected by outliers so much, but the mean is. Particularly when you've got a small amount of data, that it can be affected either way and pulled either way. And that's why sometimes mathematicians prefer to use the median. Okay. I think before we finish, we'll just have a look at one question from exercise 2a, and I'll just go through this one question with you. And the question was this one, okay, and it was question 5 from exercise 2a, and it was at a haulage company. Now, a haulage company is a company that has lots of trucks, and they go out and they move heavy goods around for companies and so on. And in their brochure, trying to sell themselves, we'll move your stuff for you. Okay, they talk about how many breakdowns their fleet of trucks have, and this is the table, and it's the number of breakdowns per month, so over a period of time. So you can see here that 8 months they might have had all of their fleet out and they had no breakdowns at all, but there were 11 times, a frequency of 11 times, where they had 1 breakdown in a month, and 12 times where they had more than 1, but they had 2 breakdowns in that month, and so on. And we've got to find, you're asked to find in the question the mean, the median and mode, so it's very GCSE, isn't it? If we do that very quickly, we're just simply saying, 0 times 8 is 0, 1 times 11 is 11, so that's 11 breakdowns. They broke down twice, 12 times, so that is 24 breakdowns, multiplying, that's 9, 4 and 5. If we add all of those up, of course, we get, let me do that, we get, 53, I've done it here at the side. We get, is it 53? It is. So we get 53 breakdowns altogether. And if you add up the frequency, okay, so this is 8 months where they had no break, 11 months where they had 1 breakdown. So 11 add 8 is 19, add 12, add 3, add 1, add 1. You'll see that the time span that they used to sample this was 36 months. So they had a total of 53 breakdowns over 36 months. Now, when you see, we talked about notation in this part of this lesson was about notation. So if we use that notation, then the mean, okay, that's a symbol for the mean is, and what we did here was the sum of x, which is the number of breakdowns, times the frequency. Okay, so that's what we did. We did that times that, didn't we? To give us the total number of breakdowns. So the sum of all of those divided by the sum of the frequencies, okay, which is 36. Okay, so you'll sometimes see it written like this, or more often than not see it written like this, certainly if we're doing the estimated mean. Okay, and that of course is equal to 53 divided by 36, which gives you 1.47. The median, okay, is the middle number. There's 36, half of 36 is 18. We find the 18th breakdown, okay, so because these are all in order, no breakdowns, 1 breakdown, so 8 and 11, so it's not in this group, is it, because this is the first 8 breakdowns, okay, sorry, this is 8 months, okay, and if we add another 11 to that, this is 19 months, okay, and we want the 18th month, which is 1 breakdown. Okay, so the median would be in that group if we put them all in order. So when we're recording those number of breakdowns, we're saying naught happened 8 times. 1, 2, 3, 4, 5, 6, 7, 8. And 1 happened 11 times. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 2 happened 12 times. 1, 2, 3, 4. So if we put all these breakdowns in order that happened, okay, we'd have 36 of them. You know, the number of breakdowns per, you know, for the 30 in each of those 36 months put in order. And the 18th one, of course, you know, would be this one here, which would be 1. Okay, it's in this particular group. And the mode, of course, is 2, because 2 breakdowns was the most common occurring, wasn't it? Because it happened 12 times. Okay, so when this haulage firm, and so often in statistics now, you're asked to describe the data and make decisions based on it. That's what statistics is all about. So unfortunately, this is where maths slips into psychology. We've got to break away from, we've got to start using our common sense, haven't we? And using the data to answer questions. We've never had to do that before. Okay, we just give a number, don't we? And that's the answer. But in the brochure it says, advise the company on which average to use to say how many. They want to be honest. They want to say, yeah, we're a company, we've got a lot of trucks out there and we do have the occasional breakdown. What's our average breakdowns per month? Okay, well, they can go with 2, 1 or 1.5 breakdowns a month. But they want to sell themselves, so they're going to go with the median, aren't they, and say we have on average 1 breakdown a month. They're not lying. Okay, it's true. If that average is the median and that's the one they've taken, they can justify that. That's the one they've taken. Okay, have a go at exercise 2A. It's very straightforward. Think about what we did. Okay, with these. Okay, we've done all those sorts of questions before. Okay, thank you. Bye bye.